A ball is dropped from a height of 23 centimeters. After each bounce, it rises to only 78% of its previous height. Determine the total distance the ball travels until it comes to rest. So let's try and visualize what's actually going on here. So we have a ball that starts out at 23 centimeters above the ground, and it would drop it straight down. So it's going to travel 23 centimeters right there before it hits the ground. It's a bouncy ball, so it's going to bounce back up, but only to about 78% of the previous height, and then it comes back down. It bounces again and again up to 78% of the previous bounce, and then back down, and so on and so forth. And the question here is, how far does it travel? So we're looking at adding up the length of all these green arrows, and as it continues here. Okay, so what we want to do is we want to start by writing an expression for the total distance traveled. So the total distance that first, when it drops from that original height, that's going to be 23 centimeters right there. Plus, so now this is going to be on the x-axis. Let's label the x-axis here as number of bounces. So this is number 1, number 2, number 3. So the first bounce, as it goes back up, is going to travel 23 centimeters times 0.78 times 2, because it's coming back down, right? So it's 23. We can label it here. We can say 23 times 0.78. That's the distance from here up to here, but then it travels down again, right? So that's why it's times 2. So that's going to be, this is the bounce number 1. Bounce number 2, so that's going to be over here. So now it travels 23 times 0.78 squared. That's the idle reach. The bound goes up and back down, so it's going to be times 2. And then we can continue here. So this is bounce 1. This is bounce 2. So let's so this is going to be 23 plus infinite geometric series. We can clean this up a little bit by multiplying the 2 times 23. So this could be written as 23 plus 46 times 0.78 plus 46 times 0.78 squared plus, and so on. And this part here now, that's an infinite geometric series. And we want to determine the total sum here. So what we want to determine is the total distance, which would be expressed as 23 plus, that's the initial drop, plus the sum of that infinite geometric series. Okay, where this expression equals to a, which is the first term, over 1 minus r, where r is the common ratio. So what we need to do here is we need to determine what the common ratio is, and we need to determine what the first term is. The common ratio, r, equals, so in this case here, if we label the terms, this is term number 1, This is term number 2. This is term number 3. Term 1 is not part of the infinite geometric series, so to get the common ratio, we divide term 3 divided by term 2. So that's going to be 46 times 0.78 squared over 46 times 0.78. And we can simplify this and just get a common ratio R of 0.78. Okay. Now the first term, A, equals, in this case here, it equals term number 2, which is 46 times 0.78. So now it's just a matter of plugging it in. So our total distance is going to be 23 plus A is 46 times 0.78 over 1 minus R, 1 minus 0.78. And if we evaluate this, we're going to get 186.1 centimeters.